Hello everyone and welcome to the lecture on AWS Organizations. So what is AWS Organizations? 1. Centralized management of multiple AWS accounts. AWS Organizations allows you to manage multiple AWS accounts from a single centralized location, making it easier to oversee and control your AWS environment. 2. Hierarchical grouping with organizational units. So with AWS Organizations, you can group your accounts into organizational units (OUs) and create a hierarchical structure that reflects your business needs, enabling better organization and management. 3. Consolidated billing and cost control. AWS Organizations provides a consolidated billing feature which allows you to receive a single bill for all your accounts and easily track and control your AWS cost across the organization. 4th, streamlined policy application across accounts. You can create and apply service control policies known as SCPs across your organization, ensuring consistent governance and compliance for all your accounts. 5th, simplified creation of new accounts. AWS Organization simplifies the process of creating new AWS accounts, allowing you to quickly and easily add new accounts to your organization as your business grows. 6th, integrated with other AWS services. AWS Organizations integrates with various other AWS services such as AWS IAM, AWS CloudTrail, and AWS Config, providing a seamless experience for managing and monitoring your AWS environment. 7th, no additional charges for AWS Organizations. There are no additional charges for using AWS Organizations, making it a cost-effective solution for managing multiple AWS accounts. So this is high-level overview. So we have this one is called the management account, and this is the AWS Organizations. So this particular management account is part of this AWS organization, and at the management account you create policies which are applied to the root. So this is called as root organizational unit. So there is always a default root OU. So when you add any AWS account, it will go to the default root OU, and you can enable cross account services and delegate to member accounts. So member accounts are the accounts which you add after the management account. So first one will be management account and others will be called as member accounts, and policies applied at root apply to all accounts in the organization. So we have the organization root, then so you can have other organizational unit OUs. So policies applied at OU apply to accounts within the OU. So it's like it will have inheritance. So this and then this will take precedence. Then OU can contain other nested OUs, and it can be up to 5 levels deep, and OUs then finally contains the member account. So this OU, for example, is containing two member accounts, and this OU is containing this member account and this member accounts. So member accounts can be delegated to administer a specific service for the organization. Okay. So organizational unit contains member accounts, can contain nested OUs. So this is the very high level overview. So I'll talk more about in the next few slides. So AWS Organizations key terminology, part 1. So first, as we have seen, organization, an entity created to consolidate your AWS accounts, allowing you to administer them as a single unit using the AWS Organizations console for centralized management. Then we have root, the parent container for all accounts in your organizations. Policies applied to the root affect all OUs and accounts. Note, currently only one root is allowed, which is automatically created by AWS. Third, organizational unit, a container for accounts within a root, enabling a hierarchical structure. Policies attached to an OU affect all accounts and sub OUs, organizational units beneath or under it. Each account can be member of only one OU. Fourth, an account which is a standard AWS account containing resources and identities. There are two types. One is management account and the second one is member account. So management account, the account used to create the organization. Manage accounts, apply policies, and enable integration with other AWS services. It also acts as the payer account. Then you have 6th, member accounts. All other accounts in the organization besides the management account. So all other are called as member accounts, and each can be a member of only one organization at a time. 7th, delegated administrator. A member account designated to manage organization policies or AWS services on behalf of the management account. There are two types: delegated administrator for AWS organizations and delegated administrator for an AWS service. Then invitation, the process of asking another account to join your organization, issued by the management account to the account ID or email address of the invited account. Accepted invitations result in the account becoming a member account. So AWS Organizations Key Terminology Part 2. 9th, handshake, a multi-step process of exchanging information between parties used for invitations and changing feature sets. Handshakes are primarily interacted when using the AWS CLI or API. Next, 10th, available feature sets. AWS organizations offer two feature sets. So one is all features, which is the default with full functionality, and second is consolidated billing, which shared billing features only. So there are two feature set, you can opt for one of them, all features or consolidated billing. 11th, service control policy, SCP, a policy that specifies the maximum permissions for an organization, OU, or account. SCPs do not grant permissions, but instead limit the permissions that can be granted. So it's like a boundary or a limiting container. Then 12th, allow list versus deny list. So complementary strategies for applying SCPs. Allow list explicitly specify the allowed access, while deny list explicitly specify the prohibited access. AI services opt-out policy, a policy that helps standardize opt-out settings for AWS AI services across all accounts in your organization, allowing you to choose to opt out of having your content stored or used for service improvements. 14th, backup policy, a policy that helps you standardize and implement a backup strategy for resources across all accounts in your organization by configuring and deploying backup plans. Then 15th, tag policy, a policy that helps you standardize tags across resources and accounts in your organization by specifying tagging rules for specific resources. Okay, now we'll see management account. The management account is the account that you use to create the organization. The management account has the responsibilities of a payer account and is responsible for paying all charges that are accrued by the member accounts. You cannot change an organization's management account. From the organization's management account, you can do the following: create accounts in the organization, invite other existing accounts to the organization, remove accounts from the organization, designate delegated administrator accounts, manage invitations, apply policies to entities like routes, OUs, or accounts within the organization. 7th, enable integration with supported AWS services to provide service functionality across all of the accounts in the organization. Member accounts make up all of the rest of the accounts in an organization. An account can be a member of only one organization at a time. So now let's see some best practices for multi-account management in AWS. So first, use a single organization for account management. Centralize control and simplify billing by managing all accounts under a single AWS organization. Second, strong passwords and MFA for root users. Enhance security by using strong passwords for root accounts and enable MFA. Third, document root user credential usage. Keep a record of when and why root user credentials are used to ensure accountability and traceability. Fourth, control for root user credential access. Implement measures to monitor and control access to root user credentials, reducing the risk of unauthorized use. Fifth, keep contact information updated. Ensure that the contact phone number for accounts is always current to facilitate communication in case of security or billing issues. Sixth, group email for root accounts. Use the group email address for root account notifications to ensure that critical information is accessible to multiple team members. Group workloads by business purpose. Organize accounts and workloads based on business needs rather than organizational structure for improved clarity and efficiency. 8. Use multiple accounts for workload organization. Leverage multiple accounts to separate workloads, which can enhance security and make it easier to manage resources. 9th, enable AWS services at organizational level. Utilize the AWS Service Console or API CLI operations to enable services across the organization. 10th, use billing tools for cost tracking. Take advantage of AWS billing tools to monitor cost and optimize resource usage across your organization. Then 11th, plan and enforce tagging strategy. Develop a comprehensive tagging strategy to ensure consistent resource labeling, which aids in cost allocation and management. Okay, some best practices for the management account, the top account or the account which has created the AWS organization. So first, limit access to the management account. Ensure only a few trusted administrators have access to prevent unauthorized changes and enhance security. Second, regularly review access. Periodically audit who has access to your management account to ensure that only necessary personnel can make changes. Third, use for essential tasks only. Utilize the management account strictly for tasks that cannot be performed by other accounts to minimize risk. Fourth, avoid deploying workloads. Keep the management account clear of workloads to streamline operations and maintain its primary administrative function. Fifth, delegated responsibilities. Where possible, assign specific tasks to individual accounts outside of the management account to decentralize control and reduce bottlenecks. Some best practices for the member accounts. 1. Define account roles and responsibilities. Clearly delineate roles within each member account to ensure operational efficiency and clarity in access control. Scale environment efficiently. Leverage AWS tools and services to dynamically adjust resources, ensuring that your environment scales in response to demand while optimizing cost. Use service control policies for security restrictions. So implement SCPs to restrict actions that users and roles can perform, enhancing the security posture across your AWS environment. Fourth, optimize account usage and cost. Monitor and analyze usage patterns to identify cost-saving opportunities. Applying cost optimization practices to reduce unnecessary expenditure. Then fifth, implement comprehensive monitoring. Use AWS monitoring tools to keep a close eye on resource utilization, performance metrics, and security configurations, enabling proactive management and incident response. Okay, next is some managing policies in AWS organizations. So we'll see types of policies and what are those and what are the policies in general. So policies enable additional management types. So policies in AWS organizations allow you to apply extra management capabilities to the AWS accounts within your organization beyond the basic account management features. Second, policies available when all features are enabled. So there, as I talked about, there are two feature sets. One is only for billing purpose and one is all features. So you can utilize policies when all features are enabled in your AWS organization, unlocking the full potential of policy-based management. So you have to opt for all features. Third, console displays policy type status. The AWS organization's console clearly shows the enabled or disabled status for each policy type, providing visibility into which policies are active in your organization. Fourth, authorization policies. Centralized security management. Authorization policies such as service control policies, SCPs, enable you to centrally control the maximum available permissions for all accounts in your organization, ensuring consistent security. Then we have management policies. Configure and manage AWS services. Management policies allows you to centrally configure and manage various AWS services and their features across your organization's accounts, streamlining administration. So under there are two categories basically. So one is authorization policies. Under that, only we have one option, service control policies, which is part of authorization policies. Then we have something called as management policies, under which there are three different types, which I'll talk about. So first, under management policies is AI services opt-out policies control data collection. So artificial intelligence AI services opt-out policies give you control over data collection for AWS AI services across all accounts, protecting sensitive information. Then under same management policy, we have something called as backup policies, which manage backup plans across AWS accounts. So backup policies helps you centrally manage and apply backup plans to AWS resources across your organization's account. This is for data protection and recovery readiness. And finally, we have one more third type under management policy, which are called as tag policies, which standardize resource tags. Tag policies enable you to standardize the tags attached to AWS resources in your organization's accounts, improving resource management and cost allocation. So we'll see a few types of policy. We'll see SCP, we'll see backup and tag policies. So service control policies, SCP in AWS organizations. So this is very popular, and this is also used for big corporation and big companies. So first, manage permissions in your organization. SCPs are type of organizational policy that allows you to manage permissions across all accounts in your AWS organization. Central control over maximum available permissions. So SCPs provide a centralized way to maximum permissions that you can grant to all accounts in your organization. Third, ensure accounts stay within access control guidelines. So by defining guardrails and setting limits on actions, SCPs helps your accounts compliance with the organization access control requirements. Fourth, available with only with all features enabled. So they are only with if you opt for all features. Fifth, do not grant permissions on their own. So SCPs do not actively grant permissions. Instead, they define the maximum permissions that can be granted by IAM and resource-based policies. They work in conjunction with IAM and resource-based policies. Effective permissions are determined by the intersection of what is allowed by SCPs and what is allowed by IAM and resource-based policies. So all come, we have to factor in or consider all three into picture, SCPs, IAM and resource-based policies, to basically effectively tell what a user or a group or an object can do or a service can do. Seventh, affect only member accounts, not the management account. SCPs impact IAM users and roles in member accounts but have no effect on the management account. Eighth, similar to IAM policies but never grant permissions. So SCPs use a similar JSON policy syntax as IAM permission policies but are solely used to specify maximum permissions but never to grant them. Ninth, restrict permissions for IAM users and roles in member accounts. SCPs restrict permissions for IAM users and roles, including the root user, in all member accounts based on intersection of SCP, IAM and resource-based policy. 10th, do not affect service-linked roles. Service-linked roles which enable AWS service integration with AWS organizations are not restricted or affected by SCPs. Disabling SCPs detaches them for all entities. When SCPs are disabled in a root, they are automatically detached from all entities, and re-enabling them does not automatically recover previous attachments. 12th, permission boundaries and SCPs must both allow actions. So if both a permission boundary and an SCP are present, both must allow an action along with identity based policy for the action to be permitted. So we have something called in accounts permission boundary. So SCP is at a higher level at organization and multi-account setup. So effectively both must have an allow action. Otherwise, even if one denies there, it will that particular action cannot be performed. 13th, use access data to identify unused permissions. Service last access data in IAM can help identify permissions allowed by SCPs but never used, enabling you to refine SCPs based on the principle of least privilege. 14th, refine SCPs based on service last accessed data. So again, this is utilize the service last access data to update SCPs, denying access to unused services, and aligning permissions with your organization's security requirements. Next is the tag policies. 1. Standardize tags across resources in organizations' accounts. Tag policies help ensure consistent tagging practices across all resources within an organization, making it easier to manage and organize resources. So within an organization, all the accounts which falls under it, so you can define at the organizational level, and that will be inherited by all the accounts. So this will help standardize the tags across all your AWS resources. Second, specify tagging rules for resources when tagged. Tag policies allows you to define specific rules that must be followed when tagging resources, ensuring compliance with organizational standards. Third, define case treatment and tag values. So you can specify the exact case treatment, for example, uppercase, lowercase, and allowed values for tags within a tag policy, maintaining consistency. Fourth, prevent non-compliant tagging requests on a specified resources. Tag policies can enforce compliance by blocking tagging operations that don't adhere to defined rules on specified resource types. Fifth, untagged resources or undefined tags not evaluated for compliance. Resources without tags or tags not defined in the tag policies are not checked for compliance, focusing only on the specified tagging rules. Sixth, use AWS Organizations to manage tag policies. AWS Organizations is the primary service for creating, updating, and attaching tag policies to organization entities like accounts and organizational units. Seventh, use AWS resource groups to manage compliance. AWS resource groups helps you monitor and manage compliance with tag policies by identifying non-compliant tags on resources. Eighth, available only with all features enabled. So you have to enable all feature sets. Tag policies are accessible only with all features, not just the consolidated billing. Ninth, understand the effects of a simple tag policy on a single account first. Before applying tag policy to an entire OU or the organization, it's better to understand how a simple tag policy affects a single account to avoid unintended consequences. So this is just a recommended or tip how to basically test it or roll out to all the OUs or the whole organization. Then 10th, comprehend the impact before enforcing compliance. Prior to enforcing compliance with any tag policy, thoroughly review and understand the potential impact on your resources and workflows to prevent disruptions. Okay, last is the backup policies in AWS organizations. So first, define how to backup AWS resources using backup plans. AWS Backup, which is a service, enables you to create backup plans that define various settings such as backup frequency, time window, AWS region, and storage vault. Apply backup plans to resource groups using tags. You can apply a backup plan to groups of AWS resources identified by using tags, making it easy to manage backups for multiple resources. Third, identify IAM role granting AWS backup permissions. You must identify an IAM role that grants AWS backup permissions to perform the backup operation on your behalf, ensuring secure and authorized access. Combine settings into JSON text documents. Backup policies in AWS organizations combine all the necessary settings and configurations into JSON text documents for easy management and distribution. Attach policies to organizations' structure elements. So you can attach backup policies to any element in your organization's structure, such as the root, OU, or individual accounts, providing flexibility in policy management. Sixth, inheritance rules combine policies for effective backup policies. Organizations applies inheritance rules to combine the policies attached to different levels, resulting in an effective backup policy for each account. Granular control over backing up resources at any level. Backup policies give you granular control over backing up resources at whatever level your organization requires, allowing for customization based on the specific needs. 8. Specify default backup settings at the root level. You can specify default backup settings such as backing up all Amazon DynamoDB tables in a policy attached to the organization's root. 9th, override backup frequency in OUs based on the requirements. So you can attach backup policies to OUs that override the default backup frequency according to specific requirements of each OU, such as once per week for developers and once per day for production. 10th, effective policy must have all the required elements. So when organizations combine all the policies for an account using inheritance rules, the resulting effective policy must have all the requirement elements. Otherwise, AWS backup considers the policy invalid and does not back up the effective resources. 11th, consider requiring complete and valid policies. So as an alternative strategy, consider requiring that all backup policies be complete and valid by themselves using default values supplied by policies attached higher in the hierarchy and overriding them where needed in child policies. So at the highest level, going all the way to account level, make sure all the policies are valid so that it will either override or it will go to the top or the root policy. So 12th, view effective backup plans in AWS Backup Console. The effective backup plan for each AWS account in the organization appears in the AWS Backup Console as an immutable plan for that account, which can be viewed but not changed. And 13th, monitor backup plan job status and errors. When AWS Backup begins a backup based on a policy created backup plan, you can see the status of backup job and any errors in the AWS Backup Console, both for member accounts and the organization's management account, if trusted service access is enabled. So you have to enable trusted service access if you want to see from management account, or directly you can see from the member account. And that's all. Thanks for watching.